The first thing I want to go over is my expectation as far as what needs to be shown work in this section. In all three sections in Moodle, for online and face-to-face, I created this slide and I recreated this uplink here. So when it's time to test on chapter 9, there are certain places where I need to see the elimination method work, and you cannot just put it all in your calculator. And after today's session, you'll kind of see how putting it in your calculator kind of works easy, but there are certain problems on the test that I require you to show work. And this is also goes for the lab also, and I'll show you the lab in a minute. So basically, when the problems look like this, solve for elimination method, solve using the substitution method, solve using, I do not know how to pronounce this name, so we're just going to say GGJ. Anytime you see this GGJ directions, you're going to be using the elimination method that we discussed in 9.2. So this here, if you see these problems on the test, on a separate sheet of paper, you need to work these problems out, show the work, and then you can click this link right here and submit your work through this link. I understand that you probably would get a 95 on this test coming up, but that grade would not signify you getting a 99, because I have not went back and checked your upload to make sure your work matches the answer that you put into MyMathWise Plus to acquire that 95. So you need to hold off on your final grade until I grade it, and I will send everybody a notification saying Chapter 9 grade has been updated and your grade is safe to assume this is what you made on your test. So once again, if it says the GGJ elimination, we're going to use the elimination method taught in 9.2. So this is for those problems. Now, on the test, if you see a word problem, obviously the directions does not have a specific use, substitution, elimination. So once you set the problem up in MyMathWise Plus or the test, or in a problem like looks like this says solve these system equations, both of these directions here does not specifically say use any one of these methods. So you can more than welcome to use the calculator technique to produce your answer. And this is one of the slides I pulled from 9.3, I think, to get to the answer to solve these two problems. So if you set these problems up right and type them right in your calculator, I do not need to see the work for these problems. You can just go ahead and put in your calculator and provide me with the answer. This also goes with the lab. So this lab here is what you also should see in Moodle. So all these problems here, I need to see work for. So I left enough space up here for you to put work and show the elimination method for the first three. Set the equations up. If this is not enough space, you are more than welcome to take out another sheet of paper and show work for each one of these problems up here. And then you submit this in Moodle as far as the lab is concerned. All right, so that's enough of that. We're going to get started with 9.3. So 9.3, we're going to start off learning how to put this matrices in the calculator, but first we got to kind of break it apart to make sure we understand how to put it into our calculator. So for here, we're only going to be using, when we start with the calculator, only the coefficients. So the 2, the -3, the 1, the +4, and the 7 and the -2. So this is how it should be written more simply as far as it's put. So we're just taking the coefficients in front. So this is considered to be a 2x3. A 2x3 meaning the 2 will come as rows. So if you look here, there's one row. This is number 2 row, and the second number would be considered to be the column. So 1, 2, 3. So if I look at this problem here, how many rows do you see? 1, 2, 3 rows. And then how many columns? 1, 2, 3, and then 4 columns. So this would be considered to be a 3x4 matrix. And this is what it looks like. So if one of the MyMathWise problems asks you to transform this equation into a matrix, well, the parts in front of the equal sign goes in front. I guess this right here would be our equal sign cutoff. So we put the 2, -1, 4, 2, -1, 4, draw the line for our equal sign, and then put the -3 there. So this is the way it should look. Nothing to it. If you are missing a letter, this is where we put 0 into with our calculator. So y was missing here. So if you want to write it out with a space, so you know that y was missing, so you put the 0 there. So this is how it transferred to look like as far as in your calculator. So here are the steps for solving these type of problems in your calculator. You want to hit second and then the inverse button, because we're trying to get to this word right here, matrix. We're going to slide over to edit, and we're going to go down to the first one and name it A. It doesn't matter, it can be a C, but since it's the first one here, we're going to name it A. We're going to hit enter. And then this pops up as far as what the matrix is going to look like. So once you pop this up, you go ahead and just place the numbers inside: 2, -1, 4, and then the last one here will be -3, then down to the next one, and so forth. So this is what your number should look like once you finish typing it in. I have a few examples that I can show you just to make sure we're all on the same page. And I have a calculator up here. So, but this is just how it transforms into a 3x4. And also too, when you get to it, make sure you name it a 3x4 up top so you can get your amount of spaces that you need. Then we hit second mode to exit out this screen. Then we're going to hit second and then inverse again, the matrix. And this time we're going to actually solve the problem. So now we're going to be actually solving for X, Y, and Z for this problem. So we're going to this time slide over to just to math, and we're going to go down to where it says RREF and then hit enter. So this is what should show up in your calculator. Now we have to go get that letter that we solved it under. We solved it under A. So we hit second matrix, and then we hit enter twice. And then the A gets put here, and then this is our answer. So what does all this means? Remember, the first column represents X's, the second one represents Y's, and then the third represents Z's, the Z. So if X, if I say X is here, what's understood to be in front of the X? A 1, right? So there's no Y's, no Z's, so X is equal to 3. So that's going to be my first answer. No X here, no Z here, so Y is going to be equal to 7. So that'll be my second part. And then X, no Y, Z is going to be equal to -1/2. So this is the parts where you can actually, when you're doing your elimination method, now on the test and everything, you're more than welcome to put this in your calculator and see what the answer should be. But if you're, like I said, if your work doesn't match your answers, then you won't receive credit for the problem anyway. But it's good to know what the outcome will be, so you'll know when you work in the elimination method or the substitution method, you'll know what you're looking for in the answer. So here's an example of a problem where in the calculator it'll show no solution. So using the RREF again, we're going to get our matrix. And then once we put it all in our matrix, so we put all this part in the matrix when we get to the problem. And then we go to the RREF. And then when we hit enter, we see that down at the bottom here, we have 0, 0, 0, and it's supposed to equal 1. Well, we already know 0 is not possible to equal 1. So anytime you have 3 zeros on the bottom and you have a number over here, that's not possible. So this is how we know the problem is going to be a no solution problem. So look how this reads out. X, no Y, but a 3 here. And remember, this column here represents Z. So we have X plus 3Z equals what? 0. That's how you write this equation in this form. There's no X, there's no Z, so Y is equal to 0 for this one. And then down here, there is no X, Y, and Z, so we have 0 is not equal to 1. That's not possible. This is no solution. So this is an example of what a no solution looks like in your calculator. So again, please be careful when you put these numbers in your calculator, because one number slip up So if we put all these numbers in the calculator and this one here is a -2, what is supposed to be a +2, your whole answer is going to be thrown off. So it's very careful that you need to make sure you double check before you go get the RREF to make sure all your numbers match your problem up top. So here's an example of what the calculator looks like if it has infinite many solutions. So this is where in these previous sections where if you have a solution equal to a solution, so if they both equal to each other, remember I told you this is where you have to do extra work and your answers for X, Y, and Z could look like equations. So this is what it looks like. So once we put in our matrix, again, this is a 3 by what? 3 by 4. 1, 2, 3, and then 1, 2, 3, 4. This is a 3 by 4 matrix. Put in the 1, -4, -1, 4, and then so forth. We hit RREF for A again. And this is the equations that we get from our answer. So this is what it looks like. So the bottom here, look at here. We have the whole line in the bottom this time is all zeros. This is going to be your indication where the answer is going to be infinite many solutions. So we write the equation X, which is right here, no Y, so we skip it. -5Z, because remember this whole column represents Z. So we have -5Z is equal to 0. That's our first line. Second line, Y minus Z is equal to -1. And don't have to worry about the last line. So now we have to go get what our X is equal to and what our Y is equal to. We can easily do that by just solving for X, solving for Y, by moving this guy over to this side and then moving this guy over to this side, and that's going to produce our answer. So if we move this out here, remember this is a negative, so when we move it over, it becomes positive. So X equals a positive 5Z. That's what we have here. If I move this guy over by doing the opposite, Y equals Z minus 1. That's what Y is. And then because Z is not present, but it is present in the equation, we just write Z at the end. That's always going to be the case when we're doing the infinite amount solutions. If you have a Z present here, a Z present here, then the answer here is just a Z. Same thing for when you were doing your work. If you had a Y here and a Y here, we're just going to write Y here. So whatever letter it represents, you just write that letter one time at the end, or wherever it's supposed to be slotted into. So this is my X, this is my Y, this is my Z. And again, when I have all zeros on the bottom, we know it's going to be infinite many solutions because 0 does equal 0. So those are your three scenarios of infinite amount of solutions, no solution, and we'll have an exact answer for the problem. And this is just a slide I took from 9.2 to show how the answer is exactly what we came up before and what I just showed you just a minute ago. So that concludes 9.3. Let's jump over to 9.4, and this is where I'm going to kind of show you an example of how to put those matrices in the calculator. So for this one here, 9.4, this is going 9.4 and 5, and I think a little bit of 6 is going to be your easy section. So please, 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 when you're doing your tests and doing the work, make sure you are typing these correctly into the calculator. So I'm going to write this off to the side and then go to the calculator to type it in so everybody can see what it looks like. And I think I can just do it like a screenshot. Yeah, I can leave it like this. All right, so I know it's probably small on your screen, but just bear with me and then I will get it to the size. So for A, we're going to type in, do the second and then the inverse button. And I have a bunch of stuff in here, but it doesn't matter. I'm going to just go ahead and change it out. So I'm going to go down to edit and change it. This first A looks like a 2 by 2. So I can leave a 2 by 2 there. So I change this first one to be -5. and then hit enter. The next one's going to be 0, hit enter, and then the next one is going to be 4, and the last one is going to be 1/2, so 0.5. So that's going to give me the first matrix here. So I'm going to go ahead and do B now. I'm going to drop down to, I'm going to go to edit first, and then I'm going to go down to B. So this is a 3x1. Remember, I want to change it to a 2x2. So enter. And now I have 6, -3, 2, and 3. So now the first part of the problem says find A and B. Find A plus B. So we're going to add them two together. So if I go back and get it, second, the matrix, and this time we're going to stay on names now. Because I changed these two and I want A and B, I'm going to go change it to names. Get the A, hit plus, go back and get B. So just drop down and get B. So this will be my answer for the first one. So looking at these problems here. Now here, they kind of show you how to do it by hand by just adding the first column together, the first row together, and second here. But for here, I don't require any work. You can just put in your calculator and you get 1, -3, 6, and 3.5. So 1, -3, 6, and 3.5, and that will be your answer for here. So it's going to be really imperative as soon as we finish, because MyMathLab is working, to go ahead and jump to 9.4 and 5 and 6. Type these answers in your calculator and just produce the answer and get this section done, so you go ahead and get it completed, and you don't have to worry about MyMathLab crashing on you later on. So for here, it's really nothing to it. When it asks for 3A, again, put this in your calculator, and all you're going to do is just say 3 times the A and then -1 times the A for the problem. So you just over here 3 times second matrix and then A, and then you hit enter. Now I'm not going to hit enter for this one because this A is different to what I put in this A, but once you hit enter, it provides you the answer down at the bottom. So once you hit enter and actually have this matrix in the box, you'll get 3, 0, -4, and 5. So just give this work these slides again, just give it a few more practice with the problem. The only thing I want to go ahead and make sure we understand is part D. So let me skip down to part D. And part D, it's saying that it cannot be done, because if we label part D, so A is going to be a 2x3, and C is going to be a 2x2. If you have a matrix that's a 2x3, and we need to multiply this one by a matrix that's a 2x2, your calculator is always going to give you an error if these two numbers don't match. Because the 3 and the 2 does not match, then this is going to be a reason why it's going to give an error, and it can't be multiplied together. These numbers here have to match in order to get the answer to be provide you an answer. Now, when they do match in the problem, so we say, for instance, we took the A, which is a 2x3, and multiplied by B, which is a 3x2. Do you see now that the 3 and the 3, they match? So because they match, you can go ahead and multiply these together legally, and then your final answer is a 2x2. Now, how did it come back to be a 2x2? Well, look at the front numbers. The 2 and the 2 That's what makes the your answer as far as the matrix. It'll happen like that every single time. So long as these match, you're allowed to multiply, and then the end parts, the beginning and the end parts of the numbers will make your new matrix as far as your answer, a 2 by 2. So for this one here, I'm multiplying at 3 by 2, 2 at 2 by 3. This 2 matches with this 2, so now I'm okay to multiply these two together. And because this first one's a 3 and the last one's a 3, it produces a 3 by 3. So 3 and then 3 columns. And that's going to be all for section 9.4. 9.5 is super easy because once again, we're just doing inverses. And for inverses, again, you just type in what they give you for A, and the inverse button is located on your calculator here. So if I go get A again, and I click this button here, the inverse button, there goes the inverse button on top. So for this particular one, when they just ask for the inverse, that's pretty much all you're doing is just putting in the problem and then producing your answer. And that concludes 9.5. 9.6 now is talking about the determinant. So I'm going to ask you to show you how to do determinant by calculator and by hand. For this one again, I do not need to see, you don't have to show any kind of work on the test for showing it by hand, but I do want to show you by hand just in case if you would like to know how to do that. So to do the determinant, especially when we have numbers as a radicals and we don't have clean numbers as far as a negative 3 or 4, the first step we need to do is, well, the formula is you multiply A, this is going to be A, B, C, D. You take your numbers and multiply diagonally. So the square root of 2 times the negative square root of 2, which is here. And then you take negative 4 times negative 3, which is here, and we're going to subtract them together. So get your answer, multiply them two together, we get negative 2 minus negative 4 times negative 3 gives us a positive 12, which gives us negative 14. So again, multiply, and subtract the difference between the two, and that provides us with a determinant. Now, a 3 by 3 determinant has to be done this way if you're doing it by hand, because multiplying it by 2 by 2 is easy, just multiply straight across here, but a 3 by 3 is what's going to be a little bit more difficult and challenging to do. But step one is once you have a 3 by 3, so here's my row, and here's my column, so this is my 3 by 3. The first thing is to rewrite the first two columns to the right. So I have 2, 0, 1. Just rewrite it off to again 2, 0, 1, and then 3, negative 2, 5. 3, negative 2, 5. So all you do is rewrite the first two. Don't write the last one, just the first two. And then we're going to come back and now multiply forward diagonally. So 2 times negative 2, which is negative 4, times 6 gives us negative 24. 3 times 4 times 1 gives us 12. And then obviously 1 times 0 times 5 gives us 0. Add them together, I get negative 12. Then we come back and multiply backwards diagonally. 1 times negative 2 gives us negative 2. And then 2 times 4 times 5 gives us 40. And then 3 times 0 times 6 gives us 0. It doesn't matter the order. You could have done it this way because we're all adding together. It's not going to throw the problem off. But once you get here, you get negative 38. Add them both together, and we get negative 50. So that's how you do it by hand. So if we want to do this by calculator, here is the determinant sign for the calculator. So let's go to the problem. So it's second and then inverse. And we're going to go over to math. And it's going to be the very first one, DET. And just hit enter. And then now we just go get back to the letter. So go get the letter that you saved it under. So it can, well, I don't know, it doesn't matter which letter you saved it under. If it's B, you saved it under B. You just type it in and it gives you the determinant of wherever B should be. So once we do this problem here, remember this is the very first problem I did in my example. So once we put it in the calculator, go to get the determinant. Determinant of A equals -14. So this is to kind of help you check your work if you did it by hand by multiplying it here and here. I think MyMathLab actually has an example of one with variables in it. So when it has variables, you just multiply it together and you cannot combine like terms, so you just leave it as is. So if you have the x here and a y here, it'll just be x times y and you just leave it at it as is. There's no solving for it. And you obviously you cannot put x and y into the matrix up here and then do the determinant. So anytime you have a variable, you have to do it by hand. So this is one of the reasons why you need to know how to do it by hand. Variables, you cannot put it in the calculator because the calculator will not produce you the right answer for x and y. That is a no-no. Please don't do that. Same thing with a 3 by 3. Just put the 3 by 3 in, go get the determinant. The answer should be 26 for the problem. So if you wanted to do it by hand, remember, write this row first, the second row here, and then draw your line diagonal each one, add them all together, and then come backwards, diagonal, add them all together, add them, and you get 26. And that is all of 9.6. So I'm going to, before we get started for here, I'm going to pause it so I'm going to actually, okay, so partial fractions, this is what the direction is going to look like. We're going to decompose into partial fractions. So obviously it comes back to our favorite topic where one of our first things we need to do is make sure we know how to factor the denominator. So the denominator factors to x plus 2, 2x minus 3. And I also put this note up here, in order to begin, make sure the degree in the numerator is smaller than the degree in the denominator. So these two have to make sure this one is smaller than this one. I don't think they have any that's like that, but if it is, we should have our techniques and where to what we need to do for that. But let's just go ahead and get started with this part. Here we're going to factor these two together, and we're going to factor this to get this part here. So x minus 4 equals 13 breaks down to be here. And because we have two parts, we're going to name it A and B. So if it was 3 of them down here, we have A plus B plus C if we have 3 of them. So it just depends on how many denominators you have as far as in parentheses is how many letters you're going to produce up here. So now we know for this one here, we can't add these two together because remember the denominators are not the same. So we're going to have to do what we have learned with the zookeeper method is figure out what's missing. So over here it's missing a 2x minus 3. And over here it's missing the x plus 2. So once we multiply this side over here by 2x minus 3, we multiply it on the top. And remember, we don't have to worry about the denominator. It's already there. So x plus 2 gets multiplied to the b on this side. And this is where we have a and b with our two ones that's missing for each part. So now that the denominator for this problem and the denominator for this problem are the same, remember back what we discussed these tarps with the zookeeper method, we can actually get rid of the bottom parts. So once they are the same, we don't need the bottoms anymore. We just set the numerator equal to this part as far as the numerator on this side. So here, this one is exactly the same. Get rid of the numerator and the denominator, and just set these both equal to each other. So this is what I have as far as what the numerator looks like. Top part equals this part. So remember our question as far as now, the next step is we need to figure out our zeros. Look at this problem here and this problem here, what would be our zeros? So we know this one will be -2, remember the opposite, and this will be positive 3 over 2. So 3 over 2 and -2. That's going to be our next step, finding the zeros. Once we find the zeros, we're going to plug both zeros into x's. Now only do one at a time. So this 3 over 2 gets plugged into this x, and this x. All the x's, you plug in this 3 over 2 into and then solve. What happens is, and the reason for us doing that is because we're trying to figure out what a and b is equal to. So it's kind of hard to solve for two different letters. So if we plug in a 0, what happens to the problem? Well, if I plug in this -2 here, what is -2 plus 2? Isn't that 0? And then 0 times this b, that goes away. Because this b goes away, we can now solve for a. If you plug this 3 over 2 into this x, this becomes 0. So now all we have to do now is pretty much solve for 3 over 2. We'll plug it into this one, and solve for this b. So that's the purpose of us finding the zeros and plugging it in one by one. So plug this one in all three parts, because so we can eliminate one of these a's and b's and solve for the problem. So if I did 3 over 2 first, so I did it here, I did it here and here, we see that this part over here, once we do the math, equals -7. When we do this part, this becomes 0. And then 3 over 2 plus 2 becomes 7 over 2b. So then I'm going to divide, since this is being multiplied together, to get b by itself, we're going to take this over and divide, and we get -2. -2 for b. Then we come back and put in -2 for all the x's. So we put in for here, here, and here. And that way this part now goes away. Multiplied here, we get 21, -21 equals to -7a. So we move the 7 over by -7 over by dividing, and we get a equals to 3. So our answers for this problem is a equals 3 and b equals -2. So we go back to the problem, a equals 3 over x plus 2, and then b equals -2 over here. So you can write it both ways. You can put the plus sign and put a -2 here, or you can drop the negative sign in front and just leave this as a positive. Both of them are exactly the same answers, and MyMathLab will accept both. A way to check your work: if you plug your original problem in for y1 and you plug your answer that you produced in y2, what you're looking for is both columns actually showing the exact same results. That's how you know you got the problem correct. So if they both match up all the way down, then that way we know a equals to 3 and b equals to -2 is the correct answer. Now I'm going to show you actually by hand, step by step. I have two problems I'm going to do step by step, but I just still want to run through as a lecture first on how to do these problems. So for this one here, we don't have to do any factoring because it's already factored for us. With this one here, this is where we're going to have the a plus b plus c part, because we actually have three parts. Because of the square, this is where we have to write this one additional time. So anytime you have a square with anything in parentheses, we write it again in our part of our answer. So here's my 2x plus minus 1 for a. My x minus 2 squared is my c. And then because I told you before it's a square, we just write the x minus 2 once again. And then we go from there, figuring out what's missing from each part. So if I look in this fraction here, what's missing? It's missing an x minus 2, and it's missing an x squared, and sorry, this part here is missing an x minus 2, and it's going to be missing an x minus 2 squared. But because we already have an x minus 2 already listed in this one, we only need to multiply the part A by just the x minus 2. The B, we'll look and see what's missing for part B. For part B, it's missing an 2x minus 1, which is here, and it's missing an x minus 2, because remember there's two of them that we're looking for. So we only put one here for part B. And the C one, the only one is missing is going to be 2x minus 1. So just to kind of recap again, the A is missing the x minus 2. Remember, it's supposed to be two of them. So that's where the square comes from. The B is missing an 2x minus 1, and just one of it, because it already has one, so it's just missing one of these parts. So that's why we multiply those together. And then the c is just missing just the 2x minus 1. So once we figure out what's missing and put it to the top as far as multiplication, we can now see that the two denominators are now equal to, or are the same, so we can get rid of them and we can just work with just the numerators. So here we got rid of the denominators and we just wrote the numerators all equal to each other. So let's figure out the zeros for each one. The zero for this one is going to be 2. The zero for this one is going to be 1/2. So the first one we're going to put in is 1/2. You put it in for all the x's. So 1, 2, 3, 4, 5, 6. We put it in for actually 6 x's. This 1/2 for the 0, we put it in for all 6 x's. Now I did not have to do it for this one and this one, because remember, if I plug 1/2 in for this one, this whole thing becomes 0. So that's why this came into play. If I plug 1/2 for here, this part becomes 0. So 0 times this b or this one becomes this 0 here. So like I said, once you start to get the hang of it and doing some problems, once you start plugging in your zeros, you'll notice how a lot of these letters go away and you're only just working with one letter. So once I plug it in here, do the math, squaring it, times in it, we get 45 over 4. And then if I do it here, I'm getting 9 over 4a. So these are being multiplied together, take this over by dividing, and we get a equals to 5. Now we got to come back and do 2. So I'll plug the 2 in for all the x's. Remember, if I plug 2 in here, that becomes 0, goes away. Plug 2 in for this one, that becomes 0, all this goes away. So really the only one that's actually going to produce an answer is the last one. So we multiply those together to get 3, divide it, and then we get c equals -2 for answer here. So the only thing we're missing here is b now, because we have a as an answer, we have c, but we just don't have b, because every time we plugged in one of our zeros, this always went away. So this is what you need to do for this one. To find b, we choose any value except for the 2 we already chose, 1/2 and then 2. Like I said, it does not matter which one you choose. You can choose any value for b to solve for b. I think the easiest one to use is 1. So we plug in 1 for all the problems. This time we have to do it for every single one. And notice too, we also plug in for our a and our c the numbers that we got for our answers. So don't forget that when it's time to choose to solve for b, and you choose any value that you want, 1 being the easiest one, don't forget to plug in your a and your c for -2 also into the problem. Because again, we don't want to solve for a and c all together. So we don't want to solve for a and c, so we plug in our values that we already found for a and c, and then we just solve from b now. We do all the math, and we notice that b equals to -1 once we actually simplify and reduce the problem. So a equals 5, b equals 1, and then c equals 2. So once again, just to repeat, when you choose any value, so instead of 1, if I would have chose maybe 5, no, I can't choose 5 because yes I can. If I choose x equals 5, and I'll plug 5 in for everyone, your answer is still going to be 1. If you choose 10 and plug in 10 in for each one, your answer is still going to be 1. So like I said, it's just easier to choose 1 because the math will be a little simple, a little bit easier. So a equals 5, b equals 1, and then c equals -2. And again, you can put the negative in front and just leave this as is if you want to. So that's how you do one where you have a square. So anytime you see a square, you're going to have 3 parts, but make sure you just rewrite the square part, whatever's in parentheses, for our b, and then our c goes last for that part. So this is the example if the degree is larger than the degree it is on the bottom. So this is here, this is when we have the one that's large to it. So this is what we need to do. We go back and do our long division. We go back and do long division, and then we're going to take the 2x plus 3, put it in front, and then whatever our remainder is what we're going to actually use for our partial fraction. So the remainder is what we're going to start our partial fraction form. We don't really worry about the 2x plus 3. This is the part now we actually go ahead and start the decomposite of the problem. So this reduces down, this is factors to 3x plus 1 and x minus 1. Then you have to put your a, then your b, like so. And then I didn't actually show out the work for this one, but just to lay it out, a is equal to 5 and then b is equal to 1 for this one. So this is my last example, then I'm going to actually show you two by hand how to do the problem again. But just in case you run into a problem that looks like this now, we have 2x squared. This time the square is in the inside of the parentheses. When the square is on the inside of the parentheses, this is where we write ax plus b now. And then x minus 3 for this one. And this is the type of example I do have that I'm going to show you. It's pretty lengthy, but hopefully that once I write it out and kind of draw it out, you kind of understand how to go about getting the answer for a one that looks like this. But just to keep in mind again, if the square is on the inside, we're doing an ax plus b as 1, and then the last one is just going to be our c for this one. All right, so let's move towards my two examples. So the first one we're going to do for this one is, again, we're going to take the denominator and we're going to factor it. So if we do our factoring technique, either by calculator or by hand, whatever you prefer, this is going to factor to be 7x plus 4, and it's going to be 4x minus 3. So this is where we come over and put the a and b now. So we have a is going to be over 7x plus 4 plus the b, which is going to be 4x minus 3. So from here, we're going to figure out what our zeros is going to be. If you set this one equal to 0, we're going to have negative 4 over 7. If you set this one equal to 0, we're going to have 3 over 4. So we're going to keep these off to the side for right now, and we're going to come back and plug those in once we have it started. So all this here, remember, we're going to figure out what's missing. So if I look on the A side, what's missing is going to be the 4x minus 3. So we're going to say both top and bottom 4x minus 3. And we're going to multiply it by the A. So for the B, what's missing is going to be the 7x plus 4. Once I figure out what's missing, remember the bottom one stays exactly the same. And because this bottom here matches the bottom up top here, we can go ahead and eliminate both sides, and we just set the top and bottom numerators equal to each other. So I have 40 So again, here's my zeros. Remember, if I plug this 0 into this one here, this whole thing goes away. So basically all I'm doing is really plugging it into this one and this x to figure out what my answer should be. And we already know that this one here becomes 0, so we don't need to do that part. So once you put all this in your calculator, 40 times this fraction plus 7, and then 4 times the fraction plus 3, we're going to get, and this is a lot to put in the calculator, so I'm going to trust that everybody kind of already knows how to put in the calculator. We should get a equals 3 for the first part. So multiply all this together, bring it over by dividing. Whatever this result is, the answer should be 3 for this problem. So now we're going to take this problem again, and we're going to plug in the 3 over 4 now to every part. So I have the 40, 3 over 4 plus 7 is equal to, now I'm not going to plug it into the A one because remember this one will go away as far as 0. So I'm only going to really plug it into the B part. So 7, 3 over 4. And this is going to be our B. So once I get the answer for over here, multiply this together and then add 7, get our answer. Then I multiply this 7 times the 3 over 4 plus the 4, get our answer. Take this answer, divide it on this side. B is actually going to equal to 4. So once we have our A and B, we can come back and write our final answer. So it'll be 3 over 7x plus 4 plus 4, which is our B, over 4x minus 3. Okay, so this is where this problem here gets kind of lengthy. Remember when you have the square in it, this is where we have to do the ax plus b part. So hopefully I have enough space for all this and everybody can follow along, but just bear with me. I'll try to put as much detail I can on this screen. So we already know that the problem is going to look like this is a plus c over x minus 3. So once again, if I have the square here, this is where I do the x, ax plus b, and then the second part just gets to c for that part. So now we figure out what's missing. So the c is missing this side. The ax plus b is missing the x minus 3. So we just kind of multiply, show the multiplication for that part. So I have ax plus b, and it's going to be times x minus 3. Then I have c, and it's going to be times 4x squared plus 1. Now that we already know the bounds match up, so all this part here is actually going to be equal to the numerator up top here. So negative 17x squared minus 13x plus 7. So like I said, the numerators go away once we figure out what's missing. And now we have just dealing with the top part, the numerators set equal to each other. Now the next step here is just we're going to actually FOIL. So we have to actually do our FOIL technique and get the answer for this part. So if I FOIL, that gives me ax squared. This is going to be minus, because I'm going to take it to the negative 3ax. Now I'm going to do the b's and the x together. That gives me plus bx. And then this b times the negative 3 here, that gives us minus 3b. For the last part, I'm just going to take this and FOIL inside of both. So I'm going to have plus 4cx squared. So this c times the 4x squared gives us 4cx squared. And then this c times the 1 gives us plus c. So now I'm going to combine like terms and actually combine like terms and FOIL out the ones that actually look the same. So if I kind of highlight this x squared and this x squared, it seems like I can pull out an x squared and leave it on the outside, what leaves me with just the a and the 4c left over. So I'm going to have a plus 4c, and I'm going to pull out the x squared. So just to kind of recap what I just did, if you take this x squared in and multiply it to this a, do you agree you get this ax squared? If you multiply this to this 4c, you get this 4c squared here. So all I'm doing is combining these two, but I FOILed out a x squared, put it on the outside, and just left with the part that's supposed to be left over in the inside. The next part, I'm going to combine the x's together. So if I kind of highlight this x here and then this x here, we can pull out an x on both sides. So we can say plus a minus 3a plus b with the x on the outside. So just to recap what I did here, if you take this x, distribute it in for here, I get the negative 3ax, so this x here, and then if I take this x multiplied to b, I get the bx here. So actually I just take these two, took out the x for both of these parts, and written what I have left over on the outside. The last part is just going to be minus 3b plus c. There's really nothing that you can take out of this one or this one, so we just kind of drop that down, this 3b here and this 3b here, so I have this whole equation here. So now looking at this equation here, we can start setting things equal to each other now. So normally in a polynomial equation, the number in front of the coefficient in front of the x squared is designated to be our a, this is our b, and this is our c. Remember the quadratic formula? If I ask you to fill in the quadratic formula, this is my a, this is my b, and this is my c. Well, it goes to the same way. This is my a because it's in front of the x squared, this is my b because it's in front of the x, and this whole thing is considered to be c. So all I'm doing now is setting this a equal to this a, and then dropping the x squares on both parts. So I'm going to have negative 17 is equal to a plus 4c. The other equation is going to be negative 13 is equal to negative 3a plus b. And the last one is going to be 7 is equal to be negative 3b plus c. So once again, I think I can get it from here. This a came from the number in front. of ax squared. This negative 13 came from the second one, and the 7 came from the last number in the equation. So this is my A, this is my B, this is my C, and I just put them in here. So this came from here, this second part came from here, and then this part came from here. So these are the equations now I'm going to be working with. Almost done. Y'all stay with me. So what we're going to do now is we're going to solve for A, because now we need to figure out what A is equal to, what B is equal to, and C is equal to. But since I got too many letters going on, I'm going to have to use what we learned in 9.2 and do some elimination method to get rid of some of these letters so I can just solve for one letter at a time. So let's take this equation up top and let's solve for A. If I solve for A, I can move the 4C over by subtracting, doing the opposite. That goes away. So A is equal to negative 17 minus 4C. So why we do this? Because this is going to be helpful, because once I replace this A doing the substitution method in for this A, all I'm working with now is B and C. That's going to help us do the elimination method in just a minute. So I'm going to take this whole A, plug it into here, so I can just work with these two equations, my B and C. So negative 13 is equal to negative 3 in parentheses, negative 17 minus 4C plus B. So I took this whole equation here, replaced it with the A, and now I'm going to simplify this equation. So I distribute the negative 3 inside. Negative 3 times negative 17 gives us 51. Negative 3 times this negative 4 gives us a positive 2. These two negatives give me a positive 12C. And then write the B here. This negative 3 does not get multiplied over to the B. It just goes what's inside the parentheses. So I can combine the 51 over here and bring this over. That's going to leave me with so all I did was just switch these two around. So I brought this over by subtracting. So minus 51, minus 51. Those cancel, and that gives me this negative 64. And I just switched these two because I want my B to be first and I want my C to be last, so I can join it with this equation here. So these two equations now, I'm going to join together to do the elimination method. So in order to do the elimination method, remember we have to try to eliminate one of these letters. I think since the 3 is the smallest one, if I multiply everything on the second equation by 3, the 3's will cancel out. It's like doing that LCD thing. So we can rewrite this one. This one is fine. However, this one here, if I multiply this whole thing by 3, I'm going to get negative 192, 3b plus 36c. So when we add them together, they cancel. So what it leaves me with is when I add 7 plus negative 192, I'm going to get negative 185 is equal to 37c. Divide both sides by 37. And C will be equal to -5. Finally, we did all this work and we found out one of these letters is what it's going to be. So now we just got two more to find. We need to figure out what B is and then figure out what A is, and then we're actually done with the problem. So now we just need to plug in C to one of these equations. It looks like if I plug in C to the first equation, I can actually figure out what A is. So let's do that. So I'll take the first equation, -17, A plus 4 times -5. I'm going to take the 20 over by adding. That cancels out, giving me with A is equal to 3. So I got my A, I got my C, and now it's time to get to B. And for B, it looks like I can choose maybe this one here, because if I know what my C is, plug in my number for C, solve for B, I can get my final answer. So 7 equals -3B minus 5. So again, I'm plugging the C in for the -5. I'm going to add 5 to both sides. That gives me 12 is equal to -3B. Divide both sides by -3. So B is equal to -4. All right, finally finished. We got my A, my B, and my C. So now we go back to the original problem where we had it set up. So this is what the setup looks like. We had the AX plus B over 4x squared plus 1 plus C over x minus 3. So for this one here, what is my A? My A was equal to 3. So it's going to be 3x plus B. What's my B? That was -4. So I'm going to go ahead and make this a -4. All over 4x squared plus 1. Plus C. C was actually equal to -5 over x minus 3. And this will be my final answer for the problem.